This is Fred. Fred woke up this morning with a dull pain in his abdomen. Since Fred is a smart guy, he decided to go to the emergency room. He had symptoms of appendicitis. The first thing the doctor did was count Fred's white blood cells. She explained that people with appendicitis tend to have a higher white blood cell count because the body is fighting an infection. However, Fred had a relatively normal white blood cell count. The doctor said, "Fred, don't worry, we have another test that involves something called nuclear medicine. It uses radioactivity to diagnose a disease." Fred was like, "What? What the heck is radioactivity?" Radioactivity is the emission of subatomic particles, the doctor explained, or electromagnetic radiation that is produced by certain atoms' nuclei. Radioactive emissions are great in the medical field because they can pass through matter like skin and muscle. During Fred's second test, antibodies were tagged with radioactive atoms and then injected into Fred's bloodstream. And since antibodies fight infections, they naturally zoom towards any areas of the body where there may be infections. So Fred really did have appendicitis. The tagged antibodies would gather at his infected appendix. After some time, Fred was placed under a photographic film attached to a panel. The test was positive. This means there was a lot of radioactivity emitting from Fred's appendix. Fred was diagnosed and treated immediately. Radioactivity saved Fred from a lot of pain. There are 5 main types of natural radioactivity that we know of: alpha decay, beta decay, gamma ray emission, positron emission, and electron capture. We're going to put asterisks next to this one because it's a bit of a special case. Okay, so before we start to understand the types of radiation, we need to recognize some notation. X is the chemical symbol for the element, Z is the atomic number, so number of protons, and A is a mass number, protons plus neutrons. The notation for subatomic particles is pretty similar. We have electron, proton, and neutron. The top numbers are to differentiate between their relative masses. The bottom numbers are to represent the relative charges in terms of protons being present. Okay, let's look at alpha decay. Alpha decay occurs when an unstable nucleus emits a particle made up of 2 protons and 2 neutrons. Since this here is identical to a helium-4 nucleus, the symbol for alpha radiation is the same symbol for helium-4. When an element emits an alpha particle, the number of protons in its nucleus changes, which causes the element to transform into another element. This is illustrated by this nuclear equation. As you can see, in a nuclear reaction, elements often change their identities, which is different from a chemical reaction. The sum of the atomic numbers on both sides of a nuclear equation and the sum of the mass numbers on both sides of the equation are always equal. The equation must be balanced. The alpha particle emitted by a radioactive nuclei is relatively massive. They're used in things like smoke detectors. They have the lowest penetrating power, meaning because of their sheer size, they can't easily penetrate matter. Beta decay. Beta decay occurs when an unstable nucleus emits an electron. But wait, how can a nucleus made only of protons and neutrons emit an electron? In an unstable situation, a neutron actually has the ability to transform into a proton, which then allows an electron to be emitted. It's easier to understand when looking at the nuclear equation of beta decay. See how everything balances out? Beta particles are a lot smaller than alpha particles, so they have higher penetrating power. They can be used to detect and destroy cancer cells in things like eyeballs. Gamma ray emissions. Gamma radiation is a form of electromagnetic radiation. Gamma rays are high-energy photons. They don't have any charge or any mass when they're emitted, so it doesn't change the mass number or atomic number of the element. Gamma rays are usually emitted alongside another type of radiation, like alpha decay. These rays have extremely high penetration power. They can be used to kill cancer cells, used for X-rays, and nuclear medicine, which is why Fred now knows he has appendicitis. Positron emission. Positron emission occurs when an unstable nucleus emits a positron. What's a positron? A positron is also known as the antiparticle of the electron, meaning it has the same mass as an electron but the opposite charge. If a positron and an electron come in contact with each other, they'll destroy each other and release energy in the form of gamma rays. In this type of radioactivity, a proton turns into a neutron and emits a positron. When this occurs, an atom emits a positron. The atomic number of the element lowers by 1, because now it has one less proton. Electron capture. Electron capture is a little different because instead of emitting particles, it absorbs particles. It occurs when the nucleus steals an electron from the inner orbital of its electron cloud. The net effect of this electron capture is a proton converting into a neutron. Again, it makes a little more sense when we look at the actual nuclear equation. See how, again, everything balances out? And since the element loses one proton, the atomic number again lowers by 1. Fred would like to thank you for watching this video. He hopes that you learned something new.